Alright, hi everyone. As promised, I will be sharing to you this pre-recorded lecture on the alkynes. Okay, now let us proceed on this part. Okay, so first of all, what is an alkyne? So alkyne is a hydrocarbon as well. Okay, the difference between alkyne and alkene is that alkyne, it contains a carbon-carbon triple bond. Okay, and you are going to have two types of alkynes, which is the terminal and internal alkyne. So what are the difference? Is just that where the triple bond are located. If the triple bond is located like here, this is towards the end of the carbon chain, so we will call it terminal. If it is within or inside the carbon chain like this one, okay, we will call it as internal alkyne. Okay, so as you can see, because it have triple bond, and of course you will always have one sigma bond, correct? So the other two are 2 pi bond. So I hope you still remember if how many degree of unsaturation does alkyne have. Can you predict it? Okay, so basically you still remember the rule of thumb. If you have one ring, that will give you 1 degree of unsaturation. If you have 1 pi bond, that will give you 1 degree of unsaturation. Therefore, for alkyne here, it have 2 degree of unsaturation because it have 2 pi bond. Okay, now with regards to the extra information here on the interesting alkynes like acetylene, which is a good fuel, you can read it on your own. And this one as well, like where can you find alkynes in nature, in this like poison from frog like you, yeah, right? Okay, so that's it about the introduction. So let us go to the handouts and try to complete the handouts. Okay, so if you go, this is part 8, so this in page 26. Okay, so let us go to look what is alkyne. Okay, this is alkyne, right? Please correct this, I'm sorry. Okay, so wait, let me correct this one. This should be alkyne. Okay, okay, so first of all, what is an alkyne? So what is an alkyne? So let us just follow what we did with the alkane and alkene. We said it is a hydrocarbon. So alkyne is a hydrocarbon, okay, with, okay, remember what are the different, what is a functional group? With carbon-carbon triple bond. Okay, or instead of writing like this, you can also write carbon triple bond straight away like that. Okay, and what are the types of the alkyne that you can have? You can have 2 types, okay, which are the terminal alkyne, okay, and you can also have internal alkyne. Okay, so what are the difference? Let us take butane for example. Okay, for example, butane. So you can have but1 ine. Okay, so for example, okay, this is example. Let me put example. Okay, so example butane. So 1, 2, 3, 4. Okay, so this is the butane. Okay, next, okay, another example for the internal. Okay, so for the internal alkyne, okay, for example is but2 ine. Okay, so this one, the drawing is going to be a straight line like that. Okay, why is it like this? Why I have to draw straight line? Why I don't draw like this? Okay, the reason relies in the bonding. Okay, so for the bonding of alkyne, for example, this is internal, okay, this is terminal alkyne, this is your but1 ine, okay, or 1 butane. Okay, so this one, if you see, this is a triple bond. I hope you can see this. I don't know if it is close enough or not, okay, but your butane here, it is going to make this bond and this bond to have 180 degree with one another. So this one, okay, it is 180 degree. So at the carbon-carbon triple bond, it will make a 180 degree bond. Okay, so this is a but one ion. So you can see this is the structure. Okay, you have 4 carbon, 1, 2, 3, 4, and this carbon is attached to 1 hydrogen. So this one is 1 butyne. Okay, this one is example of internal alkyne. Okay, so for internal alkyne, you can see when there is triple bond, the what do we call this? The angle is going to be 180 degree to one another. Okay, for both are 180 degree. This one also 180 degree. All right, so you see it is in a straight chain. Okay, it is not like alkane. Okay, if alkane, it is going to be 109 degree like this, but this is alkyne, so it will have a straight chain like this. Okay, and you also see that in this straight chain, okay, you have 1 sigma bond and you have 2 pi bond. So 2 pi bond will equate to 2 degree of unsaturation. All right, okay, for your information, we can also have a compound with more than 1 triple bond. Okay, for example is like this. Okay, 1, 2, 3, 4. Oops. Okay, so 1, 2. Okay, so like this. Okay, and then 1, 2, 1, 2, 3. Okay, and then maybe okay, 1. Okay, so like this. Okay, 1, 2, 3, 4, 5. Okay, so you have 5 carbon. Okay, so you have 5 carbon, so this is going to be pentyne. Okay, so 5. All right, okay, that's it about the introduction of alkyne. Okay, so you need to remember what is alkyne. It's not really remember, but you need to know alkyne have triple bond, and among this triple bond, you have 1 sigma bond and 2 pi bond. 2 pi bond meaning to say 2 degree of unsaturation. Okay, so next we are going to look into the nomenclature of alkynes. Okay, so in terms of the nomenclature, what is the difference? If you see here, alkynes are named in the same general way that alkenes are named. Okay, so we use the IUPAC system, except that the suffix are going to be different. As you can still remember, the suffix is going to represent what is the functional group that we have. So if we have alkyne, the suffix is going to be Y and E. And then, okay, now let us look. Remember, how do you name alkenes? Okay, so what is the parent's name? The parents is going to be the longest chain. Okay, but you need to remember the longest chain with, okay, the longest chain with, okay, carbon-carbon triple bond. Okay, so when you want to find the longest chain, you must make sure the carbon-carbon triple bond is there. Okay, and then about the prefix, remember carbon-carbon triple bond, okay, will get the lowest number. Okay, other than that, okay, all other what do we call it, prefix naming and rules, they are going to apply. Okay, so other rules, they will just apply similar. Okay, that is why for this one, okay, I am not going to go step by step. All right, we are just going to look into example. I don't have much example as well, but I have one only in this module. All right, so but in exercise 6, maybe I think I do have given it to you. I don't know. All right, So this one, if you have a look at this one, okay, this is an alkyne, correct? So the suffix is going to be Y and E, okay. So let us take a look. What is the longest chain? Remember, the longest chain or the parent chain is going to be the chain with carbon-carbon triple bond, okay? So 1, 2, 3, 4, 5. So this is the longest chain, okay? Let me highlight the chain. Okay, this is the longest chain. So the longest chain is 5. So 5 meaning to say it is pent. Remember? So it is going to be pent. Okay. So now you combine the parent chain plus suffix. So parent plus suffix going to become pentyne. Okay. Next, we are going to look into the prefix. But you see, we don't have any, what we call this, any substituent, alright? So you don't have to care about that. Okay, next, when you want to number, you make sure you number it this way. 1, 2, 3, 4, 5. Why? Because you want to make sure that the triple bond gets the lowest number. So this is going to be, okay, this is going to be, okay, so remember, carbon-carbon triple bond is at carbon 1, okay? You want to give it the lowest number, so it will become pent-1-ine, okay, or you can name it as 1-pentyne, okay? So that's it, okay? So let us have a look on if you have more than one triple bonds, like you have 2 triple bonds, we will call it as diines, okay? And then if you have 3, we will call it as triines, and so on, tetra, and so on. So, but it is not very critical. Okay, the simplest alkyne you can have is ethyne, okay? But usually we will call it as acetylene, okay? This is the common name, alright? It's not what we call as IUPAC name. IUPAC name is ethyne, but the common name is the acetylene, okay? And if the alkyne group is located as the, what do we call this, as the substituent, okay, we will call it as ethenyl group. So here, because 1, 2, right? So ethynyl cyclohexene. This is the parent, okay? Alright, but no need to worry much, okay? It will not be very complicated, okay? So we are done with the nomenclature. So lastly, we are going to look at physical properties before we move on to reactions. So physical properties. The properties of alkynes are just almost similar, and the trend are almost similar to other hydrocarbons. So what type of IMF are also similar. So I am not going to discuss this in detail. So let us just straight go to this one, okay? So let us go back to the alkyne here, okay? On topic alkyne. So with regards to IMF, so what is the intermolecular forces present in alkyne? Can you make a guess? Okay, so I hope you guess it right. Okay, so the intermolecular force is going to be London dispersion force. Okay, so when you have only London dispersion force, this compound is technically non-polar. So if it is non-polar, it will dissolve in what? Okay, it will dissolve in non-polar solvent. Okay, so remember, like dissolve like. Okay, so non-polar compound dissolve in non-polar solvent. Alright, next we are going to talk about the boiling point, okay, or melting point. Okay, with regards to the boiling point, okay, between different type of organic compound like alkyne, alcohol, okay, between the hydrocarbon here, because it is not covered in our lecture note and it is also a bit more complicated because you need to consider whether it is internal, terminal, and so on. So this is not covered in your syllabus. Okay, so I'll just scrap this off. Okay, so between alcohol, alkyl halide, so the concept is the stronger the IMF, okay, the higher the boiling point. So if you compare alcohol, okay, versus alkyne, of course, okay, this one will have a lower boiling point, okay, and alcohol will have higher boiling point, given that, okay, given that the number of chain are similar. Okay, next, you can also compare alkyne with another alkyne, but they have different number of carbon. I hope you still remember about this, okay, because the higher the number of carbon, okay, basically the higher the surface area, so the higher the boiling point of alkyne. So this one similar also if you have a straight chain, okay, a branch one, okay, so more straight, higher boiling point. Okay, so more straight chain, okay, or I'll just put higher number of branching, more branching, you are going to have lower boiling point. Or in another word, more straight the chain, okay, the higher the boiling point. It just, they carry the same meaning. All right, okay, done with what is alkyne. Okay, what is alkyne, how do you name it, what are the intermolecular forces present, and how do you compare the physical properties, which is the boiling point. Okay, so that's it. Now about the reaction of alkyne. Okay, let us move to the reaction. So of course, when we talk about reactions, we need to know how can you prepare alkyne, and also what are the reactions that alkyne will undergo, which is you have addition reaction, but we are going to focus on hydrohalogenation and halogenation. This one we will focus more. Okay, all right, so here recall that, okay, alkyne can be prepared by elimination reaction. So this one we have shared with you what are the types of organic reaction we can have. So among that are addition, elimination, and also substitution. So the most common method, the only one, is that you can produce alkyne from elimination reaction. For example, from germanyl dichloride, that compound must have two halogen group like this on the same carbon or different carbon. Okay, anyways you will get alkyne. Okay, anyways you will get alkyne. All right, so now let me just because this is just introduction, okay, we just want to mention it. Okay, so generally, okay, alkyne are going to be active for what kind of reaction? So alkynes, they are going to be active for addition reaction. If you see here, why? Because they contain pi bond. Okay, for your information, pi bond easily breaks. Okay, so they will tend to break and make addition reaction. So this is similar concept like alkenes you have. Okay, all right, sorry. Okay, so usually when you want to react alkynes, okay, with the compound, for example X and Y, okay, there will be two sequential steps, step by step. Okay, so firstly they will produce from alkyne will produce the alkene. It will produce something with one pi bond, the first bond break. You see, one pi bond break become one sigma bond, one pi bond, and then you add another X and Y, so you will get one sigma bond on the left. Okay, so this is already saturated. Okay, so you have 4 new bonds. Okay, because 2 pi bond broken, 4 sigma bond formed. Because the concept in elimination reaction, if you break 1 pi bond, you have to add 2 sigma bond. So here you remove 2 pi bond. So 4 sigma bond is going to be formed. Okay? Alright. So here, for alkynes, you can have, or basically you can add a lot of compound. Okay? For example, if you have add 2 equivalent of HX, which is like hydrochloric acid, hydrobromic acid, hydroiodic acid, or hydrofluoric acid, okay, you will get this product, okay, which is dichloride. Okay, but usually X is just Cl, Br, and I, because fluorine is going to be too reactive. Okay, so or you can add chlorine gas or bromine gas to, okay, X2. So you add them, all of these are going to be, you are going to have 4 chloride, tetrachloride. Okay, or you can add with water and H2SO4. This is going to produce ketone, hydration, or you can have oxidation. These 2 reactions are not very important. We just want to mention it to you, so you don't need to worry much. Alright, sit down, relax. Okay, now we want to talk about hydrohalogenation, and you don't need to worry. We are not going to ask you about mechanism and so on. This one, you just need to know that when we add, they will tend to form germinal dihalide. Why it is going to form germinal dihalide? Okay, because of the Markov-Nikov rule. So you see, for example, you add HX, right? So let's say the X is the Cl. Okay, so let's say this is Cl. Okay, so if you add Cl, the one hydrogen, okay, the hydrogen will go here and the Cl will go here. Alright, for example. Okay, you add this one, you add 1 equivalent of HCl. If you add 2 equivalent, meaning to say the next step will continue, which is you add another HCl. Alright, so this HCl, okay, this hydrogen will be added here and the Cl will be added here. So why do they tend to go and being added at the same carbon? This is because of the Markov-Nikov rule. Okay, so remember about Markov-Nikov rule, remember that it is always hydrogen will tend to go to where there is more hydrogen. Hydrogen likes to go at the carbon, okay, likes to attach to the carbon that have its friend. Okay, so for example, like this, right? Okay, like this, if you have your butane, for example, here, so this one HCl, okay, so this one, all right, when it want to add, okay, it can be added, okay, the H, let me just highlight, okay, let me highlight this properly, okay, here, this is hydrogen, can you see, it is added here, okay, and the Cl here is added here. Alright, so now, because of the Markov-Nikov rule here, now you need to ask, do you want to add the H at this carbon or this carbon? Okay, so the question is, do you want to add the hydrogen here or hydrogen here? So you need to consider Markov-Nikov rule, because based on Markov-Nikov rule, okay, remember, the hydrogen will be added to carbon that contains more hydrogen. You see? So now you compare, look at these 2 carbon. Okay, this carbon, it have 1 hydrogen attached directly to it. Okay, this carbon have 0 hydrogen attached directly to it. Therefore, okay, the hydrogen will tend to be added to that carbon. Okay, so your Cl will be added to this carbon. Alright, so that's why your product is going to be, okay, let's say this is your H, so it will be added here. Okay, this is your Cl, Cl will be added here. So you see they will form Cl like this on the same carbon equivalent. Okay, so they are going to form germinal dihalide. Germinal meaning to say at one carbon you have two halogen. Alright? Okay. So you can also add only one equivalent of HX. This one will produce vinyl chloride. Okay? Vinyl chloride. Alright? So this one, okay, this one, it will also follow Markov-Nikov rule. Okay, for example, you look your hydrogen here. Look at hydrogen. Hydrogen, will it go to this carbon or it will go to this carbon? Which one? Okay, so if you want to make it make sense, we follow Markov-Nikov rule. Okay, the hydrogen will be added to this carbon, the first carbon. Okay, so this one will not occur. Okay, why? Because of Markov-Nikov rule. Okay, so your hydrogen is added here. Meanwhile, your Cl is going to be added here, right? Okay, or this could be your hydrogen. Depend, not a problem. Okay. Okay, all right. I hope that is clear for you. Okay, next is about the addition of X2. So similar, if you add two equivalent of X2, you are going to form tetrahalide. Tetrahalide meaning to say that is a compound with 4 halogen. Okay, for example, like this 1, 2, 3, 4. Okay, butane. Okay, you have 2, 2, 4, 4 tetrachlorobutane. Okay, so because it is tetrahalide, right? So for this one, you just need to know. Okay, but maybe this one you need to understand, okay, where it is being added. Okay, so if you look at these handouts, okay, so these are the reaction of alkynes. Okay, but as I said, we just discussed these two in detail. Okay, these two not very critical. We just mention it to you so that if you go to undergrad, this is not so alien to you. Okay, all right. So let us have a look, okay, before we end this lecture for alkyne. Okay, so which one is the product of hydrohalogenation of propine? Okay, so for example, propine, how does a propine look? Okay, like this. Okay. Okay, sorry, give me 1 minute. Okay, so this is propine. Okay, so this is how it looks like. All right, okay. So which one is the product for hydrohalogenation of propine? Okay, so propine is like this, 1, 2, 3, carbon, okay, carbon. Okay, so this one going to be hydrogen, okay, of course here, no hydrogen, so here you have CH3. Okay, so remember the first one is that, okay, it is going to add with HBr. Okay, let's say this is our HBr. Okay, the first equivalent of HBr. So now the hydrogen, the HBr, let me just draw it here. Okay, HBr. So the hydrogen here, will it tend to be added? Okay, this hydrogen. Okay, the question is that it is going to be added to this carbon or this carbon. Okay, so now this hydrogen, okay, remember one pi bond will be broken, so I am going to break this pi bond. Alamak, susah ni. Okay, done. I break this bond. Okay, so I am going to break this bond. Susah benar. Okay, so when you want to add okay, so let's see, leave it here. Okay, so when you want to add the hydrogen, do you want to add to this carbon or this carbon? Remember Markov-Nikov rule. Okay, remember Markov-Nikov rule. Markov-Nikov said that the hydrogen will tend to go where there is more hydrogen. You just need to look at these two carbon. Okay, look at these two carbon. Okay, this carbon have one hydrogen attached to it. This carbon have only one carbon attached to it, another carbon. So the hydrogen will tend to go here. Okay, so this one from the HBr, okay, the hydrogen will tend to go to this carbon. Alright, okay. Now, if the hydrogen go to this carbon, okay, meaning to say your Br will go to this carbon, correct? Okay, so your Br will go to this carbon. Alright, done. Okay, next is you are going to have another addition of HBr. So let us draw this one. See, H2, okay, CH3, Br. Okay, now let us add another HBr. Okay, another one equivalent. So you have another one equivalent of HBr. So now again, do you want to add the first hydrogen? The hydrogen, do you want to add here or here? Okay, so if you have a look on this carbon, there is already 2 hydrogen. So based on Markovnikov rule, the hydrogen will tend to go to this carbon. Alright, so one pi bond, another pi bond will be broken. Okay, okay. So one pi bond will be broken. We will use this one to add the hydrogen. Okay, so the hydrogen, the new hydrogen form will be here. Okay, it's fine lah. Okay, this one panjang pendek, not so worrying, don't worry. Okay, so another Br will be added here. So can you see that you are going to form like this? Okay, so it is going to be carbon carbon because this pi bond is broken. Okay, so you have H3, okay, and you have Br CH3. So now, what is the name of this compound? Okay, so the name of this compound is 1, 2, 3. So 3 is propane. So at carbon number 2, you have 2 Br. Okay, so 2,2-dibromo. Okay, dibromo. So 2,2-dibromopropane. So the answer is C. Okay, that is how you answer organic question. That's why you need to understand about the Markovnikov rule here. Okay, this is the only one rule that we introduce you. Later you are going to have another rules. Okay, so I think that is all for the alkynes. Okay, so now let us move to the second part of this video, which is we are going to move to the part 4 in chapter 6 on the oxidation and reduction of hydrocarbons. So what are we going to learn here is that we are going to look into the reduction of alkyne and alkene, right? Because we are talking about hydrocarbon. So, but of course, before you move on into the reaction, we need to look into what is the oxidation and reduction reaction. Okay, after we get to know what is oxidation and reduction reaction, we are going to look into the reduction of alkene and alkynes. So when we talk about the reduction, of course, you must have the reducing agent. So we are going to learn this together. After we learn about the reduction, then we move to the oxidation. So the oxidation, we will focus more on the oxidation of alkenes and alkynes because we are in the topic of hydrocarbons. Okay, so let us move on. So this is the learning outcome. So you should know by the end is that what is oxidation reaction, what is reduction reaction, and how do you want to predict the product based on the catalyst used, based on the reagent used. Okay, so we are going to look into that. Okay, so first of all, what is oxidation and reduction reaction? Of course, you still remember oxidation is the loss of electron, reduction is the gain of electron, but that one more if you're talking about the, what do we call this? You are talking about those reactions in electrochemistry. So here in the sense of organic chemistry, you will see more in terms of addition of bonds and removal of bonds and so on. So for oxidation reaction, it is a reaction that, okay, it will result in an increase in the number of CZ bond, usually carbon-oxygen bond. So oxidation, you add oxygen. Just remember like that, okay? And a decrease in the number of carbon-hydrogen bond. So let us take a look at our handouts, okay? So this is at page 29, okay? So here in the reduction and oxidation of hydrocarbon, first of all, the properties, which is the carbon-oxygen bond. So just now, I have just mentioned to you. So what is the properties for the reduction of the hydrocarbon? So what happened to the carbon-oxygen bond? Okay, so carbon-oxygen bond will increase, okay, here because we are talking about the oxidation here, all right, okay. So the number of oxygen bond, carbon-oxygen bond will increase. Meanwhile, the number of carbon-hydrogen bond will decrease, okay, all right, okay. So next, okay, if you have a look here, okay, next, reduction results in a decrease in the number of carbon and Z bond. So it is just a vice versa to the oxidation, because reduction is just a reverse process of oxidation. So it will result in decrease of carbon Z bond or carbon oxygen bond mainly, okay, and it will increase the carbon hydrogen bond, okay. So now let us have a look at these handouts, okay. So here what you should feel, carbon oxygen bond in reduction reaction will decrease, okay, or reduce, okay, and the carbon hydrogen bond is going to increase, all right, okay. So this is the properties of reduction reaction. Reduction, if you see something that have a lower number of carbon oxygen bond, okay, then it is a reduction reaction, and vice versa, okay. So let us have a look here. For example, okay, for example here you have a methane here, alkyne, all right. So this is a methane. So if you see in methane, all of it are, okay, so all of it are carbon hydrogen bond. So you see here you have 4 carbon hydrogen bond, right? Okay, now it have produced methanol, okay. So here you produce methanol. Can you see this one? Look at the carbon, around the carbon. So around the carbon you have 3 carbon hydrogen bond, correct? 3 carbon hydrogen bond, okay. And you have 1 carbon oxygen bond. So 1 carbon oxygen bond. So you see from here the number of carbon hydrogen bond decrease and the number of carbon oxygen bond increase. Therefore, what types of reaction is this? Okay, because the carbon oxygen bond increase and the number of carbon hydrogen bond decrease, therefore, okay, this part is going to be, okay, if you go forward reaction, okay, so if you are going forward, this is oxidation reaction. That's why we add 1 equivalent of oxygen atom, okay. You can add in terms of ozone or so on, okay. So moving on to this one, okay, if you have a look here, okay, the carbon hydrogen bond, you have only 2. So 2 carbon hydrogen bond. What about the carbon oxygen? Okay, you see here, this is carbon oxygen, but it is double bond. So you can consider you have 2 carbon oxygen. So again, if you are going this way, this is another oxidation reaction. Okay, so this one, another oxidation reaction. So then if you reverse, okay, if you have the reverse of this is going to be reduction reaction. That's why you need to add the hydrogen, okay. You see, because you need to add hydrogen going this way, because you have 2 carbon hydrogen, you want to make it 3 carbon hydrogen, so you must add one equivalent of hydrogen atom, correct? Okay, so let us have a look here. So if you have from alkanes, I'm just going to add here alkanes to alcohol. Okay, so what kind of reaction this is? This is oxidation reaction. Okay, but if you are going the reverse way, this is going to be reduction reaction. All right, okay, so next, if you have a look at the concept of the oxidation reduction, why not we look at into alkyne, alkene, and alkane, because we are talking about hydrocarbon, right? Okay, sometimes two carbon atoms are involved in a single oxidation or reduction reaction. Okay, so basically if you look at this one, okay, alkyne here, around the alkyne here, how many carbon hydrogen bond do you have? Okay, around the carbon-carbon triple bond here, okay, around this one only, okay, 0 carbon hydrogen bond in this one only. I'm talking about the carbon here. Okay, but look at this carbon. Okay, look at this carbon and this carbon. So you see, you have 1 carbon hydrogen, 2 carbon hydrogen. So here you have 2 carbon hydrogen bond. So you increase the number of carbon hydrogen bond. Therefore, this one, of course, yes, you do not add any oxygen and so on. So, but you still have addition of carbon hydrogen. So, if you have an increase in carbon hydrogen bond, okay, what kind of reaction is it? Increase, reduction. So, it doesn't have to always meet both. It can be one of it only. So, here, so this one is considered as what do we call this? A reduction reaction. Okay, so reduction. So the reverse is going to be oxidation. Okay, now from alkene, you have 2 carbon hydrogen bond. Now look at this one. You have 1, 2, 3, 4. So you can see you have 4 carbon hydrogen bond. So if you have 4 from 2 to 4, meaning to say there is another reduction reaction. Okay, so that is how. So you can see if you go from alkyne to alkene, okay, so what happened to the saturation of carbon-carbon bond? Okay, so the saturation of carbon-carbon bond, I am referring to the carbon-carbon bond here, the saturation will decrease. Okay, meaning to say from alkyne, okay, saturation will decrease, meaning to say you will have lower number of pi bond. All right, okay, so if oxidation increase, okay, so here look at the alkane. So from alkane, just now we have just discussed it, so I'm not going to write this in detail. So alkane to alkene, okay, alkane to alkene, this is going to be oxidation. Alkene to alkyne, this is oxidation. Why? Because from alkene to alkene, you are decreasing the number of carbon hydrogen bond, or you are increasing the terbalik. Okay, I'm sorry, terbalik. Okay, but that's fine. Sorry. When we talk about the saturation of bond, meaning to say saturated bond is carbon-carbon bond. Okay, so if it is carbon-carbon double bond, it is going to be unsaturated. Sorry. Okay, so here from alkane you go alkene, so this is saturated, become less saturated, so decrease in the saturation, so it will become oxidation reaction. So you can also just look at carbon hydrogen bond, or you want to look at the saturation, not a problem. Okay, so from, if you are going to go on different way here from alkyne to alkene, because you are increasing the number of carbon hydrogen bond. Increasing meaning to say this is reduction reaction, this is reduction reaction. All right, I hope that is clear for you. Okay, so because I said you can change from alkyne to alkene to alkene, and from alkene, alkene, and alkyne. Now I want to discuss only on the reduction, which is going this way. Okay, so here, reduction process. Okay, so going this way, reduction process, I am going to discuss that. Okay, so when you want to you want to do reduction, okay, like this and so on. Okay, you see this one, this is what we call as the reducing agent, the one that is going to cause reduction to happen. So the reducing agent, you can have three types. Okay, so the three types of reducing agent, so the reduction, okay, they are just going to be different in how the hydrogen is being added, because we talk about the reduction process. Reduction process, you want to add hydrogen, right? You want to add hydrogen here to add hydrogen here, right? So how do you want to add the hydrogen? So how do you want to add the hydrogen? You can add it in three ways. So the simplest reducing agent is the hydrogen gas itself. Okay, so look at this one. The simplest reducing agent is molecular hydrogen. So if you look at the handouts here, okay, reducing agents, you can have molecular hydrogen. But if you want to add molecular hydrogen, you must add together with catalyst. They must be a pair. They must come together. Okay, do you understand? Okay, so here they must come together. So you look, reduction using hydrogen are carried out with a metal catalyst. For example, palladium metal, platinum metal, it is metal catalyst. Most of it using palladium catalyst. Okay, all right, all good. So this one, addition on alkene. Okay, so next part is, okay, so a second way is to add 2 protons and 2 electrons. What is a proton? Proton is H plus. Remember that. Proton is H plus. So if you have 2 proton, 2 H plus, and 2 electron they are coming from different source, okay, this is also equivalent to 2 hydrogen atom, which is H2, 2 hydrogen atom, correct or not? Okay, so I hope you understand. You just want, the point here is just we want to add hydrogen, okay, but the hydrogen can be added by adding molecular hydrogen, or you can add proton like H plus. So but the H plus is not molecular hydrogen, it's not hydrogen, so it is proton, it is hydrogen without electron, so you need to add with 1 electron. So where is the source of hydrogen plus proton, okay, and where is the source of electron? So you must mix, okay, you must mix, okay. So we will use alkali metal as a source of electron, because if you remember, okay, for example, sodium is alkali metal, right? So it will tend to remove electron easily. So if 2 sodium will give 2 sodium ion and 2 electron, because they will tend to remove its electron, correct? They will tend to donate. This one you remember, okay? And liquid ammonia. So the liquid ammonia here, so ammonia, we are going to use it as a source to provide H plus, okay? So from 2NH3, it will dissociate into NH2 minus NH plus. So what will happen is that these two, they are going to become NaNH2, okay, NaNH2. Okay, but this one is just a side product. We don't care. What is important, we just want to add 2 proton and 2 electrons. So this is equivalent to 2 hydrogen atom, which you can add one each on the carbon. All right. Okay. Next, okay, so here dissolving metal reduction. So dissolving metal reduction meaning to say you add sodium plus NH2, NH3. So why? Because this one will become source of electron, 2 electron, and this one will become source of 2 proton. Okay, so this one should be 2. Okay, all right. Okay, you can put notes there if you want. Okay, and then the last method to add 2 equivalent of hydrogen. Okay, you can add 1 hydride, 1 proton. Hydride is hydrogen with additional electron. So it is hydrogen with 2 electron. So hydride H minus. Because H minus, you add with H plus, what will happen? Okay, H minus plus H plus will produce 2 hydrogen, okay, or it will become H2. So equivalent to 2 hydrogen atom you want to add on each carbon. That's why this is another type of reducing agent. So now where does this hydride will come from? Okay, this hydride, okay, will come from sodium NaBH4 and lithium aluminium hydride. Okay, so sodium borohydride or lithium aluminium hydride. So for example here, you have sodium borohydride here. So remember boron, right? Boron here, it will tend to give out B, okay, H3 plus H minus. Okay, so this one, this electron will be taken together with the H minus. Okay, so this one coming from, okay, metal hydride, because your sodium is metal, right? So metal hydride. So where does the H plus will come from? Where does the H plus will come from? The proton. The proton will be added from water or alcohol. Okay, so water or alcohol. Okay, like for example methanol. Okay, because like water, it will become H plus and OH minus. Okay, the H plus is the one that is being taken. Actually H3O plus lah, but it's fine. Okay, we just want to make it easy for you. So you see, alright, so when you want to add this together, you must add sodium borohydride in water. Okay, in water or in alcohol, in methanol, ethanol. Okay, hydride and proton. So because why? Hydride plus, okay, proton will be equivalent to 2 hydrogen or H plus, right? Okay, so where does this come from? This one will come from metal hydride. Okay, you must mix the metal hydride with water or alcohol. Okay, for example methanol here. Okay, so that's it. These are the types of reducing agents. Okay, okay, now we are going to look into the reaction for the reduction of alkynes or alkenes. Okay, so first of all, I am going to talk about reduction of alkene. Okay, so meaning to say here alkene. So this is our alkene. So the reduction of alkene will produce, see, reduction of alkene will produce alkene, right? Reduction of alkene produce alkane. So the production of alkene and into alkene. So you see, this is hydrogenation reaction. We call this catalytic hydrogenation. Why? Because we add H2, molecular hydrogen, with metal catalyst, usually palladium, okay, or platinum or nickel. So this one will straight produce alkene. Okay, so if you have a look here, addition on alkene, so it will become, okay, alkene will produce alkane. Okay, so alkene will produce alkane. So alkane. So here, sorry, hydrogen, 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 hydrogen. Let's say this is, make it simple, ethane. Okay, sorry, ethene. So become ethane. So hydrogen, 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 hydrogen. So remember, you are adding H2. So let me just put this the color. Okay, H2 under the presence of catalyst. So the catalyst you use, for example, platinum or palladium or nickel, depend. Okay, not a problem as long as it is metal catalyst. Okay, now next, that's it. Okay, so when it is added, you need to understand they will be added in a syn fashion. Just remember about syn and anti-addition. Okay, so here it is going to be added into syn addition. In the case that you have stereogenic center, okay, or you have like cis and trans alkane and so on, you are going to add it in the syn addition. So this one to make here, okay, if you look at this carefully, why it is important here, this one is your carbon. Your carbon here is a stereogenic center. This is the reason that I want to teach you stereochemistry first. So stereogenic center, this is also stereogenic center. If you do and round it here, okay, this one, okay, around, let us have a look at around this carbon. Okay, around this carbon is going to be number 1, okay, it is going to be like this. Okay, here is number 1, this one number 2, number 3. So 1, 2, 3. Okay, so this 1, 2, 3, okay, if you rotate, will become R. Okay, this one will become S. You can try it on your own. Okay, so this one, you can put notes, okay, notes, okay, it will add by syn addition. Syn addition meaning to say it comes both from the front. Okay, next, okay, next, okay, I don't want to discuss this too detailed and so on, right? Okay, okay, so if you look at, if you add catalytic hydrogenation of cis and trans, okay, the cis is going to produce more heat because, okay, because this one have higher energy. Okay, so maybe you want to put this one, cis alkene, okay, produce, okay, more heat. That's it. Okay, okay, so now, okay, now I am going to move for the reduction of alkyne. Okay, I am going to move to reduction of alkyne. Okay, reduction of alkyne. So for the reduction of alkyne here, look at alkyne. Okay, if you carry a reduction, right, you can produce either alkene or straight away you produce alkene. So there can be two products. One is alkene, one is alkyne. Okay, clear? Okay, so if you want to do reduction of alkyne, you can produce alkene, or you can produce alkene. So here reduction, this one also reduction. Okay, so how can you say you can have three products, for example like this, you can produce alkene or you can produce alkene, but the alkene can be cis or trans. So how do you want to make sure you produce cis alkene and this one you produce trans alkene? No worry, we're going to go one by one. We go with this one first. Okay, all right, so if you want to conduct reduction of alkyne to produce alkene, okay, this one, okay, it is going, you use the metal catalyst. So here, okay, if you add on alkyne, okay, basically, all right, alkyne here will produce, okay, it will produce alkene. Sorry. If you use catalyst metal, it will produce alkene. All right, so here, if you look at this one, okay, this is your alkyne, right? Alkyne, if you react with molecular hydrogen plus metal catalyst, you will get, okay, first you will get alkene, after that you will get alkyne. But you need to understand this one is intermediate. You cannot separate it. Once you conduct catalytic hydrogenation, you will produce alkene. Okay, so you will produce alkene. So here, when you have alkyne, okay, this one will straight produce alkene. It will not stop at alkene. You need to understand that. Okay, will produce alkene. So here, hydrogen plus palladium, okay, or platinum. Okay, all right. Here, next, addition on alkyne. Okay, so if alkyne, if you use the catalyst that is not metal catalyst, we call it as Lindlar catalyst. Okay, next. Okay, all right. Here, the product is cis-alkene. Cis-alkene. If you want to produce cis-alkene, you must use Lindlar catalyst. Lindlar catalyst, a lead. Here, this is a bit complex lah. Okay, but you just call it Lindlar catalyst. So if you use Lindlar catalyst, okay, you are going to produce, okay, cis-alkene. For example, 1, 1, 2. Sorry. Okay, let's say you have a butane, you are going to produce, okay, cis-butene, like this, okay. With this one must be hydrogen plus Lindlar catalyst. Okay, must be Lindlar catalyst. Only then the reaction will stop at alkene. It will not proceed to produce alkene. Okay, but if you use metal catalyst only, it will just proceed straight away produce alkene. It will not stop at alkene. Okay, so next is that you have reduction of alkyne. Okay, but you want to produce trans-alkene. So if you want to produce trans-alkene, you need to use this reaction, reducing agent. So addition on alkyne. So here, from alkyne here, if you use metal reduction, you will get a trans-alkene. Trans-alkene. Okay. For example, just now like here, butane, okay, butane will produce, okay, so butane, okay, here this one will produce trans-butene with the, okay, with the rule that you need to use dissolving metal reduction, which is sodium NH3, okay, sodium, NH3, or you can use other metal. Okay, for example, sodium, that's how they write it. Okay, sorry. Okay, like that. Okay, so that's it. Okay, so for the reduction, so as a summary, you see, if you have alkyne, you can produce alkene, cis-alkene, or trans-alkene. Okay, but you need to use different reducing agent. Here, you use hydrogen with metal catalyst. But here, you also use hydrogen, but with Lindlar catalyst. And this one, you use dissolving metal reduction. Okay, I hope it is clear. So, last but not least, if you have a look here, from alkyne to alkene to alkene, you can from alkene to alkene oxidation, alkene to alkyne oxidation, done. Okay, but also from alkyne you can produce carbonyl containing compound, or from alkene you can produce carbonyl containing compound. When you have carbonyl, meaning to say it is compound with oxygen, correct? So if it is with oxygen, meaning to say this is oxidation reaction. Okay, so this is oxidation reaction. So I am not going to go into detail on this. It's just that this reaction is what we call oxidation. But if you want to be specific, we call ozonolysis. Why ozonolysis? Because you use ozone and it is going to cause lysis. Lysis meaning to say it is being cut. Okay, so lysis. So if it is like this, okay, if the reaction is like this, so it is going to be cut here. Okay, so this side, okay, on this side, okay, you will add oxygen. Okay, and this side you will also add oxygen. So that's why here will produce ketone or aldehyde. So it will be ketone or aldehyde. Okay, all right. So sometimes if it is you use here is what do we call this, terminal alkyne, is it internal, sorry, my bad. Okay, internal alkyne. Okay, so you can also produce carboxylic acid. So whatever it is, carbonyl containing compound, it comes from ozonolysis. So this reaction, okay, for alkenes, okay, this is ozonolysis, because you add ozone and it will cause lysis. Okay, so well, that is all for the lecture here. Thank you for listening. I hope that you can do all the exercises provided. Okay.